Hi, welcome to another episode of McClutchy Maths. My name is Natalie McClutchy and today I'm going to be taking you through a 4-part series on annuities. As always, you can contact me on mcclutchymaths@yahoo.com. This particular video series is aimed at Year 12 General Maths students in Queensland, Australia. In this video series, in part 1, you're going to be finding out firstly what an annuity is, and we're going to calculate the future value of an annuity in 3 ways. Firstly, using the compound interest formula. Secondly, with a recurrence relation, and thirdly, using the iterative function on your calculator. So I hope you've got your calculator handy with a pen and paper. Let's get started. So firstly, you might be wondering, what is an annuity? It seems like an unusual word. It's probably not a word that you've got as familiar in your vocabulary. Well, the word superannuation comes from the word annuity, and most of us have heard about superannuation, or super as we call it. It's an investment where our employers, so anytime in your life that you have an employer, they're required by law to set aside 9.5% of your income and then pay that into an investment fund for your retirement. Now, there's some very special key features of an annuity that make them separate from regular investments. Firstly, they attract compound interest. So we're not going to be using the simple interest formula. We're going to be using the compound interest formula. The next feature of an annuity is that there are regular and equal payments that are periodically made into the investment or received from the investment. Now, if you think about superannuation, when you earn, let's say, $1,000, 9.5% of that is going to be set aside into your employer's bank account. And then at the end of every quarter, they'll pull that money and pay that to your investment fund. And the idea of that is that we become less reliant on the government when we're retired for a pension, and we can start being self-sufficient. The third important feature of an annuity is that interest is calculated at the end of every period. So even if money is invested into that account at the day 1, then we don't actually start calculating the interest that's earned until the 365th day if we're looking at compounding annually. So that's an important feature. And you might be wondering, well, why is that the case? Why wouldn't I just deposit it then on day 364? And that's a very good question. And the way that works, for example, with superannuation in real life is that I might be earning money and going through life, but it doesn't actually leave my employer's bank account until the end of a quarter. And that's the period of when the interest starts calculating into my investment account. Now, in the QCAA syllabus, it doesn't specifically say that interest is being calculated at the end of the period. And you may find that there are some textbooks out there that are calculating it from the beginning of the period. And you might be wondering, what is the right approach on this? What should I do? Well, if in doubt, and the question doesn't tell you to calculate it from the end of the period, you should always write your assumption first. The assumption being that you are calculating compound interest from the end of every period. And I don't think it hurts to spend 2 seconds to write that assumption down. That lets your external marker or your marker at your school know what assumptions you're making before you go ahead with your calculations. Let's start with a worked example. In this particular worked example, we've got a fairly simple one here. It's a future value of an annuity where $500 is invested every year at 5% per annum for 4 years. So there's no compounding periods within the year. So we don't have to do any transformations to our variables when we get started. So that's great news. Now, each payment that we make, there's going to be 4 payments of $500, and they're going to be made and treated separately. And the compound interest is going to be calculated for each of those payments individually. Every one of those payments is going to accrue compound interest, but that will start from the end of the year where it was deposited. And it might help to show you with a diagram how that would look. So these are our 4 years that this investment is going to be alive for. Somewhere in that first year, the $500 is deposited. It's only going to be compounded for 3 years. The second $500 will only be compounded for 2. The third $500 will be compounded for 1. And the fourth will be not compounded at all. And then the sum of our future values of each of those $500 will be added together, and that will give us our future value of the entire investment. Now we're going to apply this with 4 separate calculations using the formula that down at the below of the screen. You should be very familiar with that, and it is on the QCAA formula sheet as well. I'll just quickly run you through the variables. A is the future value, or the amount at the end. P is your principal or your present value, your starting amount. I is the interest rate per compound period, and in previous videos I've talked to you about how to translate that into a new rate that we're going to use. And N is the number of total compounding periods, so that will be the number of years multiplied by the compounding periods in 1 year. Well, in this particular question, we're going to be using very simple ones. Our interest rate is going to be 0.05, which is 5% as a decimal. Our value for n will be 4. However, as you can see, we're not actually going to use a power of 4 at all because our first payment doesn't get compounded until after the end of the first year. So our starting compounding is with a power of 3. Our second payment will be compounded to the power of 2. Our third payment to the power of 1, which is simply 500 times 1.05. And I've shown this to you so you can see the pattern that's forming here. This one's raised to the power of 0, which means it's not compounded at all, because anything raised to the power of 0 is just the number 1. So 500 times 1 gives us $500. You can see no compounding for that fourth payment. Now, the sum of all of these different payments together will give us a total future value of $2,155.06. So you can see how this compound interest formula can be applied, and each payment is treated separately and then added together at the end. Now, this would be very tedious for us to use, as you can imagine, if we had to calculate it over 40 years, or if we had 4 compounding periods a year for 4 years. That means we'd have to be calculating 16 different payments and adding them together. So I'm sure you're thinking there's got to be a better way than that. Well, let's look at worked example 2. We're going to start by using a recurrence relation for an annuity. And in this case, we're using $1,000 at 2% per annum, and I've added a little bit of complexity here, compounded quarterly. So with a recurrence relation, you're going to find that on your QCAA's formula sheet. Thank goodness for that. It looks very similar to the one for a reducing balance loan. Have a look at where the difference is. Notice on the reducing balance loan, you've got A with the subscript n plus 1 equals R, A subscript n. That part's the same. But with an annuity, you've got plus D on the end instead of take away capital R, which was the repayment. So that's your key difference. Instead of taking a repayment off, you're actually adding a payment on. Now, you need to remember the value for R in this instance is it's the interest rate as a decimal, and that's going to be per compounding period. And we have to add 1 to that, because if we didn't add the 1, we'd actually be reducing the amount of our investment, which we don't want to do. We want to increase it. So in this case, where we've got 2% per annum, we're going to divide that by 4 because it's compounded quarterly, and then we're going to add 1. So that ends up giving us an interest rate or a value for R of 1.005. And we're going to use that number to substitute into our recurrence relation. So we replace the little letter R with 1.005, and notice I've added the plus 1,000. Now, you might be thinking, but isn't our starting amount going to be the amount of 0 because we're not compounding it? Well, the answer is no, because we compound our beginning amount and then we add 1,000 on after we've compounded. And that's how a recurrence relation works for an annuity. And notice I've got the little comma there with the A subscript 0 is equal to 1,000, because our starting payment, normally our A0 is the principal, but our starting payment is going to be $1,000. So that's the first part of this one. Now we have to use this recurrence relation to find the value of the investment after 1 year. Now remember, we're talking about compounding quarterly, so we've got to use this recurrence relation 4 times to get ourselves to a future value after 1 year. So firstly, I'm going to do it for A1. So I'm simply going to multiply my $1,000 by the value of R, 1.005, and then add 1,000, and I end up with a future value of 2,005. Now A2, that 2005 drops down into the recurrence relation and replaces the 1,000, which was the value for AN, because now we're using the previous year's future value to calculate the new value. So now I've got a future value after 2 compounding periods of $3,015.03. So basically after 6 months, that's how much money I'm going to have. And then I'm going to repeat that again for the 3rd quarter. And then because there's 4 quarters in a year, I'm going to stop it right there, because remember, we don't compound the 4th payment. So we simply stop at the 4,030 when we're using a recurrence relation to calculate an annuity. Now, you might be thinking about the logic of that. How does that actually work? Well, if you remember that very first payment we added on in A1, it wasn't compounded there. But then it got compounded in A2 and A3. That first payment we put in and did compound it, it's only been compounded 3 times, and that's how we work it, 1 period less than the total number of periods. Now, once again, you might be wondering, I've still got to do a lot of working for that. What if I had to do it 16 times or 20 times? What if I wanted to work out the value of this annuity in 20 years' time? There's got to be a better way than writing a recurrence relation 19 times. So yes, there is. We can do that using technology. Now, technology includes the iterative function on your calculator. It doesn't just necessarily mean using a spreadsheet. Now, in this video, I'm not going to show you how to do it with a spreadsheet because you won't need to use a spreadsheet in your external exams, but you may need to use your calculator to use the iterative function. So I'm going to take you step by step before you do that. Now, before we do that, we need to find the value of R and show some working on our paper. So in this case, we've got a $1,000 investment. It's compounded monthly at 12% per annum. $1,000 is added every year, and we want to find out its value at the end of 2 years. So we're talking after 24 compounding periods. So firstly, I'm going to take my interest rate, which is 12%. I'm going to change that to a decimal, which would be 0.12, divide that by 12, and then add 1 to it. So I got the value of R. R is equal to 1.01, and this is the number I'm going to use on my calculator. Now, I need to work out the number of compounding periods that I'm going to have to calculate. Well, I've got 2 years, and typically I would compound that for 12 months per year. That's 24 compound periods. But remember, one payment doesn't get compounded. So I'm technically only going to be using 23 compound periods, not 24. So I take 2 years times 12 months, take 1 away, I've got 23. That's the number of times I'm going to be pressing the equals button on my calculator. Now I've got a picture here of a Casio calculator. You might have one that's slightly different. If you're using a telephone and the calculator inside your phone, I've tried it with my phone and it doesn't work. You really need to use a scientific, proper calculator to use the iterative function. So if you're using an iPhone or another phone, put it away and get a regular calculator. Okay, so the first thing you're going to do is you're going to type 1,000 onto your calculator and press the equals button. Notice on the Casio, that means you've now got 1,000 in the top left of the screen and 1,000 on the bottom right of your screen. And that's what we want. We want it to be on the screen twice. Some of you might have the word answer on the screen and 1,000 at the bottom. And next step is we're going to type in times 1.01, which is our value for R, plus 1,000, which is the amount that's being added every year. So basically, we're typing in a recurrence relation into our calculator. And now I want to make stress this, you don't press the equals button in between adding the 1.01 and the 1,000. If you did that, it would stop the iterative function from working. Now we press 23 times on our calculator, counting very carefully to make sure we don't miss one. It's always a good idea to stop every 5th or every 10th so that we can write down our working and show our teacher that we've actually used the iterative function on the calculator and that we've stopped in between to show some working. So A1 would be 2010, and that's shown on the screen. A10 would be 11,000. A20 would be 23,000. And A23, which is where we're going to stop, is $26,973.46. So if you kept pressing the equals button, counting through 23 times, that's the amount you're going to get, the future value of your investment. Remember, you've invested $1,000 every month for 24 months. So your answer that you come up with needs to be more than 24,000. This is a good way to check that you've done the working correctly. So think about that carefully. If you invested $1,000 a month, every month for 2 years, you put $24,000 into the bank, you'd be expecting to earn at 12% per annum some decent interest on that, but you wouldn't be expecting your money to double in 2 years either. So if you've got a ridiculously big answer or an answer less than 24,000, you know you've made a mistake. And it's always a good idea to think about the logic of your answer before you move on. Well, that's all we have time for in this video. I hope you've enjoyed it. Please join me for part 2, where I'm going to talk to you about how to calculate an annuity using a formula, which, trust me, way easier than using a recurrence relation or the compound interest formula. Have a great day.